In this video, I'm going to show you how I created this star chart here using entirely PixInsight, nothing else, and to show the regions that I've been recently imaging shown here in red. I've not drawn any of this and it's all done via PixInsight. It's essentially a mosaic of the outputs from the Finder chart process with a little pixel math to add the regions of imaging, but I'll go through it step by step. Here's my new imaging rig. What we have is an ASCAR FMA 135 astrograph with a focal length of 135 millimeters. I have the ASCAR off-axis guider and filter drawer, which give correct spacing to the main camera. The main camera is a ZWO ASI 2600 MC Pro cooled camera and guided by an ASI 120mm mini camera. The mount is the new Skywatcher Star Adventure GTI on a Bailback Report 112 tripod, and all controlled by the amazing ZWO ASI Air Plus. Now this setup allows me to create images nearly 10 degrees by 7 degrees, so it's great for larger targets, wider star fields and smaller constellations. Without too much effort, you can create a mosaic of images to cover even larger areas, including entire larger constellations. I've got 3 examples to show you. Just close these images down. The first one is the Cygnus Loop, including the Western and Eastern Veil nebulae and everything in between, including the Pickering's or Fleming's triangle. This image needs more data to do it justice, but it's fine for this demo. Next, we have the star clouds in the regions of the constellation of Sagittarius. Just make that so you can see that, and Vulpecula, which I've annotated using PixInsight to show the constellation lines and the borders, the brighter stars, and a couple of Messier objects. If we zoom in here, we can see Messier M71, and we look over this side, we can actually see the famous M27 Dumbbell Nebula. At this scale, we're not going to see much detail in these objects, but it's nice to take a step back and look at the wider field of view. And finally, just for this purpose of this demonstration, we've got an entire constellation of Delphinus, the dolphin. When you look at this through the naked eye, you can just about see these brighter stars and maybe one or two of the others. But just after short exposures with an astro camera, you can see the background contains a multitude of stars. There's many more even, and just for the sake of this image, I had to sort of reduce some of the stars just to make it a little bit more appealing. So that's that. So the next thing, I'm going to take each of these images and just make them slightly smaller so they all fit on a page. Let's just zoom out a little. That's that one. Let's do the same with this one. Maybe a tad smaller on that. And then Delphinus will do the same there. Okay, so it's nice to see these wide field views. But it's nice to put these in context. And if we could take a step backwards and see how they fit in with the night sky. And that's what this is here. So you can see this top image, the Cygnus Loop, is that area there of Cygnus. We've got the Sagittarius-Vulpecula star clouds here, which is this area here. And finally, we've got Delphinus there. So yeah, the main purpose of this video is to show you how I created this one single chart. I said earlier that this main chart is really a mosaic of Finder charts from each of these images. So how do we go about creating the Finder charts for each of these? Let's just minimize most of these and look at this one. So if we just make this a little bit bigger, see what we're working with. What we need to do before we can create a Finder chart, we've got to image solve it. So if you go to Script, Image Analysis, Image Solver, and I'm just going to run this for the defaults I've got here. This will take a while, so I'm just going to pause the video whilst it's running. There we are, that took about a minute. You can tell it's successful because of all these stats in here. Let's just pin that for a second. So you can see it's got things like the field of view, nearly 9 degrees by 6 and a bit degrees in this case. It shows you the right ascension and declination for various points, top left, top right, etc. So it's really quite useful. Now, what this means is now if you look at this, if you hover over any part of this image and hold down the left mouse button, you'll see various stats, but if you look at the bottom, you've got the right ascension and declination. So this has been plate solved. So this is great. So what we can do now is we need to create a finder chart for this image. And it's very simple. Just go to Process, All Processes, Finding Chart. And we'll leave it as the default. We are going to come back and run it a second time to change this, and I'll explain why in a second. But just run that by dragging that new instance on here. Should be very quick. There we go. And it's created this finder chart here. Now, what we need to do, we need to run it again, but this time make this red area transparent for reasons which I'll come on to explain. So what we do is we click on this icon here, which is for the image region. We drag that slider all the way across to make it totally transparent. And then we do it again. So we'll let that run. Just take a few seconds. Great. So there we are. We've now got two finder charts for this image, one with the image region, one without. The next step is to do the same for the other two images. To save a bit of time, I've pre-run these for each of the three images. So we've got the first two that we can see here that I've just done. And I've done the same for the Sagittarius Vulpecula star cloud here. There's those two images there. And finally the same for the constellation of Delphinus. To make this bit next easier, let's rename these images because these are a bit of a mouthful. So just for the sake of this demo, let's rename this one to be, what should we call it? Let's call it C alpha Cygnus loop. And then this one here, let's call that one exactly the same, CL, but we'll say red because it's got the red image region. So we distinguish between these two. Let's do the same for this one. This is the Sagittarius region, so we'll just call that S. And then down here, we'll call this one S red. And finally, do the same for this. So we'll call that D for Delphinus. And then finally, D red. Okay, the next step is if you go to Script, Mosaic, Mosaic by Coordinates, clear your list, and then let's just go to that. 1 second. Let's try that again. Script, Mosaic, Mosaic by Coordinates. That stays there because it's part of this. My apologies. So we'll just clear that list, and then what we're going to do is add these windows to it. We'll add all of them to it. So add windows, and we just pick the ones we need. So we want, we chose CL and CL red. We had S and S red, and we had D and D red. So we'll click OK, and we'll run that process. That's filled the screen with lots of things. Let's close a few things down to make some space. So it's created these new images here. Let's make them a bit smaller so we can get them all side by side. And just minimize this. Okay. And I'll do the same for the rest and pause the video. Okay, that script is finished. I've resized and rearranged all the views on this so you can see it a little bit easier. On the left hand side we've got three pairs. These are the ones that we had before. This is the finder chart minus, and this one here is minus the image region for each of these images, so you can see three pairs here. And the script produced these, and I've arranged them so that it's like for like. So this is the first step to mosaicing. Just noticed I've got these two the wrong way around, so let's, just for the purpose of this demo, let's get them in sync. Okay. The next thing to do is to take all these views here and save them to your hard disk, which I've done for this demo. So if I go to my work folder, Mosaic, you'll see what all six saved there. The next step is to actually create a mosaic of these images here, 3 images on the left-hand side. And we do this via this process here called Process All Processes Gradient Merge Mosaic. Clear it and then add the files, those 3. And luckily we can see the ones that's not red, but we've also got them named properly. So if you choose the not red ones, 1, 2, 3, click open. Set your type of combination to overlay and then click the apply global, and that'll take a minute or so, so I'll just pause. Great, that's finished, so close that down. And we can see here now we've got the mosaic of all the non-red images, which is great. Now you might be thinking at this stage, why do we bother with that? Why not just mosaic the ones with the red images? Well, I'll show you why that doesn't work. So if I repeat that process, so process all gradient merge mosaic, clear the decks, add the files, so we're going to choose the red ones this time, knowing it's not going to work. Open, leave it as overlay as before, then apply global. I'll pause again. Okay, that's finished, but if we look at that image, we can see it's correctly matched up the constellations and the stars and everything else, but it's made a bit of a mess with regard to these red image regions. This one here has worked fine, that one's sort of gone awry, and the one down here has just gone completely. Now you can change this around by changing the order within the gradient merge mosaic process, but it just moves the emphasis from one to another. So this is no good, so we can close this down. The next step is we want to take these red images here on these red image areas, region areas, and add them to this one here. And we do this via a very simple pixel math formula, which I'll come on to next. Now this next bit is a bit trial and error, but we'll give it a go. If we just zoom in on this one red area here and choose an area where there's no stars and press and hold the left mouse button, you'll see some stats coming up. If you look at the third row down, it says R for red, and it's roughly 0.044. And if you move around, it stays at that. Let's try the same with this image here. It's 0.044 again, and the same here. Should be the same. Yeah. So in other words, that red part of this image has a value of 0.043922. So if we think, if we were to look at the red channel and attempt to copy anything from each of these 3 images where the red channel is greater than 0.4 onto here, then that should give us what we need. So that's what we'll try next using Pixel Math. So let's open up Pixel Math, all processes Pixel Math. And here's the equation that we're going to use. Let's do it for the Cygnus loop first. And what we're saying is, let's look at this image here of the signal loop in red, where it's showing the red image. We'll look at the red channel, and if the red channel is greater than 0.4, as we could tell by clicking on that, then we're going to copy that image into the target image. If this area is not red, so in other words, like it's this grey area here, then we'll just have a target image. So if we just apply that to this, there's the first one. If we do the same for Delphinus, so it's just D, apply that. That's not worked. Because I've messed that up. Beg your pardon. Let's try this again. D. Let's try this again. Great. Then the final one is for Sagittarius star cloud. Let's do the same for that. And there we are. So we can now close down Pixel Math. We can take this image and make it a little bit bigger and see what we've got. We might want to, excuse me, we might want to use the curves transformation tool. Let's do that just to make it a bit more visually appealing. So here, for example, let's have that over there. Let's open up a preview. I've preset this to this sort of curve here to give us a better background and just make it a little bit more punchy. You can choose as you wish, really. So let's leave it at that. Let's apply that. Close that and close the preview down. And there's your Finder chart. So the nice thing is it shows you each night's observations in one area. As you do add more images, you can create more Finder charts. You can remosaic this to extend it, to add to this existing one, or to widen the star field. So it's quite nice to see how your images are going over time, and that's what this chart does.